I'm going to zoom away for a second. I'm sorry. But looking at some of your notes, I noticed that you didn't label these. This is called a table. This is called a graph. And this one here is called a mapping. Did you guys write the word mapping where I did? Kalia, did you? You can put that device away. So I'm just wondering, did you label this a mapping? So go back and do that. So out of bell work, I could have had you make a table. I could have had you make a graph. Why did I choose to have you make a mapping? It's the one you're least familiar with. It's the one that's newest to you. That's the one you need the most practice with. So that's the one I picked. Am I wrong about that? All right, so back at it. Let's look at our mappings. Great job, everybody who were able to, refer back to your notes or to use the people in your group. So when I draw this, I do some nice, soft corners. This one's domain. Somebody holler out, what's a domain again? X values, short and sweet X values. So I put the 5, the -3, the 7, and the 2 in the domain. In the ranges, Y values, maybe I'll even label this. You don't have to put this, but maybe I will. And then I'll put the Y's here, 4, 2, 3. Really important that you don't write the 4 twice. So I'm not putting another 4 here. It's a map. Maps have lines drawn from the starting point to the destination. Input, output, input, output, input, output. 2 heading right up to 4 is my favorite part. Of course I did that. Yes. That's what your mapping should look like. Number 2, this is a relation. It's a set of ordered pairs. We call it B. Our nice little soft corners. We got our domains and our ranges. 5, -3, 7, 5. Similar, but not the same. 1, 2. Oh, I shouldn't have this twice. All right, so let's map this out. 5 goes to 1. -3 goes to 2. 7 goes to 3. 5 goes to 4. Number 3 is where I want to see fireworks going off in your brain. Oh my God. Relation A could be called a function. Okay, one person knows it's been a firework. Okay, so I'm gonna go ahead. Relation A could be called a function. So I can write the word function under here. It's a functioning relationship. Relation B is not a function. What? What? Okay. In your group, figure out the difference and write a statement. Explain the difference. Why is number 2 not a function, whereas number 1 is? Once you feel like you got a beautiful statement that I can write on the board for everyone, let me know. You got a beautiful statement? Actually, lots of good statements in the room. Don't question facts. But if they're lying to us and they're both functions, just calm your little conspiracy theory mind down. There's no conspiracy theory. The rule for functions is that each domain, which we know means each x value, is paired with only one y value. Should I say range? Yeah. Let's be consistent with our vocab. And then in parentheses, you guys have to write this, by the way. I mean, maybe you wrote a nice statement, but this statement is really good. The rule for functions is that each domain x value is paired with only one range y value. In relation B, in relation B, 5 is paired with both 1 and 4, breaking the function rule. Comma? I need an English teacher. Breaking the function rule. Semicolon? I'm done. That's my period. I'm done on that. That was it. So the rule for functions is that each domain is paired with only one range. In relation B, 5 is paired with both 1 and 4, breaking the function rule. Heard quite a few of you are familiar with that, and that's awesome. So pretty much the whole point of today's lesson is just knowing this rule for the rest of your life and not forgetting it. Okay. So this will show up on your exam in May. It'll show up on the SAT. You'll be reminded of it like pretty much every year in high school and math. So we just want to settle in on this, think about it, talk about it, so that it's remembered forever. Please get out your homework. Yeah, this is so I took these diagrams from something else. So this is actually chapter 1-7, if you could just fix that. All right, so a little warm up. Which situation is represented by the graph below? Take a moment in quiet. Everybody be silent. Let everybody pick A, B, C, or D. You can write on this. So sometimes it's nice just to go ahead and write right on here. All right, so it increases, stays the same, it increases. What letter matches that description? Sophia? G. All right, so here's just visual examples of the definition that we wrote up here for number 4. A function is a relation in which each element of the domain is paired with one of the range. So this mapping is a great example of a function, and so is this graph. One thing I haven't spoken about yet is the vertical line test. So if you're looking at a graph and you have to decide if it's a function, it's not as easy as looking at a mapping. If you can do a vertical line, and a vertical line is an up and down line, like a vertical jump, basketball players have really great vertical jumps, and keepers in soccer. Any other sport have great vertical jumps? Football? What are the people in football who catch the ball? Wide receivers, they can jump. Baseball players don't jump high. Volleyball players jump high. Okay, so a vertical line is just up and down, a vertical jump. So if you can draw a vertical line and you only hit the graph once, it is a function. Any vertical line through the graph should only hit once. You need to do whatever you can just to remember this by May. How are we going to remember this in May? Do you guys already remember this from last year? That's good. All right, so let's look at these ordered pairs. I'll tell you, number one, do you think that that is a function yes or a function no? Somebody raise your hand. Right. Function yes. Explain yourself, Joseph. Yes, each x value has only one y value. You don't see the same x value repeated here. Letter B, function, yes or no? Raise your hand. Yes. Letter B is a no. Can you explain, Dominic? 2 15s. 15 matches with 0 and -2, so that is a no. Letter C, somebody else. Jacob. Jacob is another no. Why? Sorry. Patrick. So, Patrick, which number in letter C ruins this? Actually, no. Because those y values can repeat. It's the zeros that are ruining it. It's the 0, not the 1, that ruins it. Okay, let's keep going. All right, so now looking at a table. So that was a list of points. Looking at a table, I'll give you guys a minute. Go ahead and answer all three. Explaining it's just going to help you remember it longer, honestly.
Also. Oh, if the relation is. Actually, no. B. Actually, I don't know. You got no.
Okay, we need to help here because E is a no while F is a yes. So we can make like a conjecture about this. So if the X repeats, no. X repeats is a no. And then over here, if the Y repeats, like I see Y is 10 twice, that's okay. Okay, so try to organize that in your head. Because some people get through this and it's a one-day lesson and they never figure it out. They just get by knowing if they see a number repeating, they just go with no. And you end up with like a 70. right? Like that gets you like through it. But look, X repeating is a no. Y repeating is A-okay. That's yes function. Yeah, that's good stuff. That's good stuff. So X repeats, no, not a function. Whereas if the Y repeats, yes, that's okay. You can have the same Y in your table. You cannot have the same X. What do I need to write better, more neatly? While you erase it, try it again. Yeah. Yes, you may. Yes, you may. If you feel like really good about your definition, yes, you don't have to explain the exact way that I explained. In fact, your explanation might be even better. Who else has a question? There we go. All right, moving on to the vertical line test. Okay, so if a vertical line hits the graph more than once, then no function. And I want to explain that. I don't want you just to memorize it. I want to explain that using these examples. I'm going to use yellow for a vertical line. So I'm going to test this. Okay, when I draw this vertical line here, I hit this little guy just once. Yellow and yellow. Try again. I hit the line just once and it was right here. And if I draw a different vertical line, I hit the line once just here. So this is yes function. Here's a no. When I draw this yellow line here, I hit the same line. I hit the graph twice. That's a no. Vertical line test. Right here. Yep. Okay, but let me explain that a little bit further. I'm going to assign this in ordered pair. What would make sense? Okay, so this is negative x, positive y. Let's say that green point is -4, +3. Let's say it's left 4 and up 3. What would this green point be directly below it? Yes. So do you see how the x value is repeating? It's the same x. So this is truly the same rule. It's just a visual representation of it. So if points stack up on top of each other on a graph, that means they have the same x value and they're breaking the function rule. Okay, this one. This is a no. Can anybody make up points that might be true for that? What's this green point maybe? Maybe it's 2, 3. Then what's this point down here? 2, -1. Again, it's the same x because they're stacked on top of each other vertically. And so that's not a function. A good explanation here that I will accept is just fails vertical line test. Yeah, let's just fails test. Let's just fails. I like that. Yes, passes vertical line test. All right, let's skip all these graphs. You guys go ahead and answer all 4 of these. There's 8. Go all the way down to the bottom where it says exit ticket. Answer these now quietly. And I'm going to put answers up as well. You'll check in and we'll be done with notes. You guys go ahead and do this quietly. Check in with what I have and we'll be done with notes. Which graph represents a function? Which ones are yes and which ones are no? You just circle the ones that are yes.
One has two zeros, two has negative seven, negative seven. Four is the only one that has four there. No, it doesn't matter if it's negative six and six, as long as it's not the same number. Like if it was negative six and negative six, then it would be no. 66, no. But since it's a graph, it's making a positive. Because our data is the graph of yeah, I think I could have guessed. I still think practice. I'm amazing at that. Weird.
So out of the first sets of graphs, 1, 2, 3, and 4, the only yes function is number 4. All of the rest are no. All right, check your answers. How do we do? We got a no, no, yes, yes.
I got four.
I messed it up. How about this? No, 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 yes. No, 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 yes. All right, you may start your assignment. Use the rest of the class to get your assignment done, and then be here without math homework. That'd be cool.
Do we give reasoning? Wait, does this one equal?
What does the directions say?
Y is 11, so y is 11, but there's no
Yeah.
This one is y equals 2x.
Let's put the y in x.
I don't know. I really do. Oh, we're doing a replacement.
Yes. Yeah, yes. If you guys could be quiet for a minute, some people are really asking me about 9 and 10. So I'm gonna go over it. So for 9, man, I don't know. I know, but you're thinking I don't know. And it's gonna be kind of hard for me to explain this as well. But for 9, let's consider replacement sets. So let's consider if x could be 1 or 2 or 3 or 4 in number 9. So if it was 1, y would be -3. Are you with me? If I put 1 in for x, I would simplify 2 minus 5 is -3. If I put 2 in for x, what would y be? -1. If I put 3 in for x, what would y be? 1. Let's do one more. It's going to click. If I put 4 in for x, what would y be? 8 minus 5. 3. All right, so what's happening to these y values? They're increasing by 2. Okay? Yeah, so long story short, do you think it's possible to put the same X value in and get two different Y values out? No, the nature of an equation, a linear equation, is when you put one X in, you always get exactly one Y out. It's not possible to get two different Y's out. So for every X, it will only be paired with exactly one Y. So for that reason, this equation is a function. You don't, but you know, if you hung with me and you understood that, you're in a really good place. You're really getting equations. I don't think you do, but I did anyway. All right, you guys be quiet so I can explain 10. These are kind of advanced ideas, and if you're motivated to learn it, I'm motivated to teach it. So y equals 11. Here's your y-axis. Y equals 11 occurs through here. At every point on the yellow line I just drew, y is 11. We got a point at 1, 11. We got a point at 3, 11. We got a point at -4, 11. Is it possible on that line to have an x repeat or two x's paired with the same y? Does it pass the vertical line test? Yes, it does. Long story short. Yes, function.
Yeah. I was like,